Hello, people. My name is Dr. Richard Barnes. We're going to have discussions on electromagnetic field theory, which is EMF for short. And in this particular course, we're going to have to touch on vectors, electrostatics, magnetism, and then we will also talk about the Maxwell's equation. Okay, so first on vectors. So what do we mean by a vector? So in simple terms, when we talk of vectors, what we mean is magnitude and direction. Okay, so the magnitude can be negative or positive, and then also it must have a direction. So the direction here could be on two-dimensional, that is x, and then y. It could be three-dimensional, that is x, y, and then z. Okay, so this is y, this is x, and then this is z. It could be three-dimensional. Okay, normally these are the two popular or typical dimensions by which we represent vectors. All right, so whenever we mention vectors, there's another thing that you also have to mention of, that is scalar. So basically this is a quantity which has only magnitude without direction. Okay, and the magnitude here can be negative or it can be positive. Okay, so that is it about them. So let's take a few examples of scalars and then vectors. So let me write here vector, and then let me write here scalar. So example of a vector here, it should have magnitude and direction. Okay, force. A force has a magnitude and a direction. Okay, displacement. Okay, it has a magnitude and a direction. Velocity, acceleration, and then others. Okay, and then others. So example of a scalar here, common example, temperature. It has no direction. Pressure, distance is just the point. Distance is just between 2 points. It has no direction, but displacement has a direction. Mass, and then etc. Okay, so that is it about scalars and vectors. And then apart from knowing scalars and vectors, it's also important that you know that scalars and vectors always act within space. So knowing about scalars and vectors, it is important to note that scalars and vectors always act within space. That is, they act within a field. Within a field. So what is called a field? So a field is a region within space. A field is a region within space where a quantity has a value. In every point or within every point. Okay, so we can have a vector field, and then we can have a scalar field. So what is a vector field? So a vector field is like, for example, within your room, the gravitational force within your room has a value at every particular point. So that is a vector field. If the physical quantity defining the field is a vector, then we have a vector field. So an example of this is the gravitational force within your room. So the gravitational force within your room has a value at every point within the room. Okay, so that defines a region in space whereby gravitational force has a specific value at every point within that particular region. Okay, so that's a vector field. Okay, so let's see a scalar field. So a scalar field is very similar. So if the quantity or the physical quantity, if the physical quantity defining the region of space is a scalar, then the field is called a scalar field. Then that field is called a scalar field. So, for example, within your room where you are, you have temperature, and the temperature has a specific value at every point within the room. So that defines what a scalar field. All right. So now we should be able to know what a field is, what a scalar field is, and then what a vector field is. Okay. So now let's see how we can represent a vector. Okay, so how can we represent a vector? We can represent a vector by an arrow like this. The arrow should have a direction, okay, and it should also have a magnitude, okay. So it should have a point where it is starting. So this is called starting point. Where it is ending is called a terminating point. So OA. So this is vector OE, okay? This is vector OE, all right? So it should also, vector OA should have a magnitude, okay? So let's say magnitude of what? OE. It should have a direction and a magnitude, okay? So this is how we can easily represent a vector. Okay, we can multiply and divide vectors by a scalar. Okay, so let's say scaling of vectors. So let's say this is vector A. We can represent vector A by this way. Okay, this should tell us that this is vector A. All right. So we can multiply vector A by a certain scalar so that the magnitude can be increased. Okay, so I can increase vector OA by a certain scalar. Okay, by a certain scalar, so that vector OA will now become like this. So you see that vector OA has been increased, okay, by multiplying it with a certain scalar. Now, if the scalar is, however, let's say a fraction or a decimal number, okay, in that case, the magnitude of vector OA would depreciate, okay, it will decrease. So it will no more be as it was before. So we can multiply vectors and also divide vectors by a scalar, okay. And then apart from that, we can also add add vectors. Okay, we can also add vectors. So let's see some vectors. So let's say we have vector A like this, and we have vector B like this. So this is vector A and this is vector B. Okay, vector A and vector B. So let's say vector OA, vector OB. So this is OB, this is what? OE. Okay. So what I can do is that I can add vector A and B. Okay, I can add vector A and B. So let's say that vector R is equals to vector A plus vector B. Okay, vector R is equals to vector A plus vector B. Okay, so direction for the vector A is like this. You cannot change the direction. You must always maintain the direction. Okay, and the direction for vector B is like this. Sorry, direction for vector OB is like this, and direction for vector OA is also like this. Okay, all right. Okay, so like this. Okay, so the resultant vector will come this way. So this will be the resultant vector. Okay, so I can put B here like this. I can put what? A here like this. Okay, I can to help you understand much more the idea of A plus B, I can draw a loop around this particular triangle of a vector. So you see that vector OB is going this way. This is A's direction. Vector A is going this direction. Okay, is going this direction. Okay, but you can see that vector R is going what? In the opposite word direction. It's going in the opposite word direction. So let me say this is what? Vector B, where it is going, and this is vector A, where it is going, and then this is the resultant vector, which is vector R. Okay, this is vector R, where it is going. Okay, you can see that vector R is going opposite to what? A and B. In this case, I can say that vector A plus vector B is equal to vector what? R. Okay, okay, or I can say that vector R minus vector A is equal to vector what? B. Okay, or I can say that vector R minus vector B is equal to vector what? A. All right. So this is how you can be able to know it. Okay, this is how you can be able to know it. Okay, so now let's see. Let's say that I still my vector vector A is like this, and my vector B is like this. Okay, just as they were before. Now let's say that I want to find vector A minus vector what? B is equals to, let's say, vector what? C. Okay, so this is how I can do this. This is how I can do this. So this is vector B. So if it is going to be negative, then the direction is going to change to something like this. Okay, see that now I have what? Changed the direction. Excuse me, let me draw it more properly. Okay, so vector B can be like this. See that I have now changed the direction. Okay, and then vector A is somewhat like this. Okay, so this is vector what? A. Okay, and then so now this is vector A and B. Okay, so now my resultant vector can be something like this. Okay, this is my resultant what? Vector. Okay, so now what I can say is that vector A minus vector B is equals to vector R. Okay, vector A minus vector B is equals to vector R. Okay, so let me draw a loop. So let me draw a loop around it to show you more. My vector A was like this. My vector B was like this. My vector A was like this. and my resultant vector was like this. So now if I should draw a loop around it, okay, you can see that vector B is like this and vector A is like this. They are going the opposite direction, okay. So and my vector R is coming this way, okay. So basically A minus B is equals to what? R, okay. Or what you can say is that vector A, you see that R and B are going the same direction, okay. So vector A is equals to vector R plus vector what? B, okay. So that is how you can also subtract what? Vectors, okay. Basically I can say subtraction of vectors, okay. Subtraction of vectors. All right. Okay. So a vector can also be represented by a magnitude and a direction. Okay. So let's say on a Cartesian plane, okay, you can have an y-axis, x-axis, and this can be a vector. By, let's say the magnitude is what? 5, and then the angle is, let's say, 45 degrees. Okay. The angle is 45 degrees, okay. And the vector can also be represented by its component, okay. By its components, let's say 2 what? 3, okay. So if I want to represent this vector, what I will do is I can have the Cartesian plane here like this, okay. So here is 2 and 3. So let's say 1, 2. Let's say 1, 2, 3. Okay, so 1, 2, 3. So 1, 2, 3 will give me something of this sort. This is 1, 2, what? 3. Okay, so this is the y component, and then y 1, 2. That is the what? X component of the vector. Okay, that's the x component. Okay, that is going this way. Okay, that is the x component. In this case, my resultant vector will be like this. Okay, so my point 2, 3 will actually be what? Here, okay. It's a vector, so I must write it what? This way. This is the way to write a vector, okay. Like this, okay. So that is how you can also represent a vector by its coordinates, okay. And then I can see that this one is a graphical method. When I draw it on a graph like this, it's what? Graphical, okay, method. Okay, we can have a series of vectors as vector A, okay. So vector A is -4 and 1, which is starting point. And vector B is 8, 6, which is terminating point. So to find vector AB, we are going to have A minus B, okay. Sorry, we're going to have B minus A. So 8 minus -4, okay, and then 6 minus 1. So AB is going to be 12 and then 5. If you want to find the magnitude of AB, then it's going to be 12 squared plus 5 squared, their square root. So square root of 12 squared plus 5 squared, which will give you 13. So now if you want to find the slope of A and B, then let's say slope, let me denote slope by M, okay, slope by M. So slope of what? Slope is M, so MAB, okay, which denotes slope. Then it's going to be y2 minus y1 over x2 minus x1, which is going to be 6 minus 1 over 8 minus 4, which is 6 minus 1 over 8 plus 4, okay, which will be 5 over 12. Let's say that we also have another vector, okay, C, which is minus 7 and then 15 as starting point. And then we have D, which is 3, 9 as terminating point. Now vector CD, okay, is going to be 3 minus 7, 9 minus 15. So CD is going to be 10, 24. It's going to be 10, 24. Okay. So now we can find the magnitude of CD. Okay. So the magnitude of CD, in terms of the magnitude, please let me just put this one here like this, okay, in terms of the magnitude. So the magnitude for CD will be like this, okay, so square root of 10 plus square root of 24, and then you find your overall, it's going to be the square root of 10 squared plus 24 squared, and this is going to give us 26. All right. So let's talk about the magnitude of CD. So the magnitude of CD is going to be y2 minus y1 over x2 minus x1, which is going to be 9 minus 15 over 3 minus 7, which is going to be 24 over 10. Okay, 24 over 10. So if we are asked to describe vector, let's say describe vector AB and vector CD, we can say that they are non-equivalent because they have different magnitudes and they have different slopes. Okay, you can see that they have different magnitudes. Okay, they have different magnitude. Okay, and then so that's the magnitude for that one, 13, and the magnitude for this one is 6. That is also different. And in terms of their slope also, you can see that their slopes are also different. So they are non-equivalent vectors. Okay. So let's talk about a unit vector. So a unit vector will always show direction, and then it will have a magnitude of 1. Okay, so let's denote it by this particular formula. Okay, so this is the formula for a unit vector. Okay, so now here, the U here is for the direction of the vector, of the unit vector, and this one is the vector itself. And this one is the magnitude of the vector. Okay, is the magnitude of the vector. So basically, V, the vector V is equals to the magnitude times U, which is the direction. So let's say that we have a vector V is equals to 4 minus 3. Okay, and then we asked to find a unit vector. We are asked to find a unit vector. Okay, so here the unit vector of V is therefore going to be the vector v itself. Okay, let me just say the vector v itself, which is 4 minus 3. Okay, over the magnitude, and this is how you find the magnitude, which is the square root of the squares of the component plus 3 squared. So 4 squared plus 3 squared, and then you find their square root. Okay, so I'm going to have 4, okay, over what? 5, okay, over 5. Okay, so u is equals to, I can write it in this particular format to denote a vector more, over 5. But I have to show that it has a magnitude of 1, but because we said that the magnitude of a unit vector is always equals to what? 1. Okay, it's always equals to 1. So here, what I can have is that I can have u, this unit vector, to be equals to 3, to be equals to 4 over 5, comma, minus 3 over 5. Okay, so I want to prove that it has a magnitude of 1. So what I can say is that I can have it to be equals to 4 over 5 squared minus 3 over 5 squared. Okay, when I do that, I'm going to get 16 over 25. There has to be a plus here. Okay, I'm finding the magnitude. There has to be a plus here. So plus 9 over 25. So I'm going to get 25 over 25. Okay, which is going to be okay, I'm saying 25 over 25, okay, which is going to be 5 over 5, which is going to be what? 1, okay. So I've been able to prove that the magnitude for a unit vector is what? Is 1, okay. So the magnitude is what? Unity, giving it the name unit vector. All right. At this point, let's try and resolve some vectors. Let's say that we have a vector in this format, 100 Newton, and then we want to find x and is we want to find the let's say this is vector f is equals to 100 Newton. We want to find the components of this vector f. Okay, the components of vector f. So vector f also makes an angle of, let's say, 30 degrees with a positive x-axis. Okay, so to find the components of vector f, that means that we must find its x component, so fx, and find its y component, fy. So in this case, we use SOHCAHTOA. Okay, so the fx, which is what? Adjacent, is going to be cos theta is equals to fx over 100 Newton. Okay, so this will give us fx is equals to 100 cos 30. Okay, and then sine theta is going to be fy over 100. So because it's the opposite, so fy is going to be 100 sine 30 degrees. Okay, so when we do that, our fx is going to be 86.6 Newton, and our fy is going to be 50 Newton. Okay, so we can say that for the vector f, okay, we can represent it in terms of vector form, okay, and then we can see that it is what? 86.6. Okay, if we want to represent it in terms of unit vector, we will bring I here, okay, plus 50 what? J, to tell us that these are the x and y components. Thus, in simple terms, the s component here is what? 50 what? I. Okay, and the y component, sorry, the s component here, sorry, let me just do it again, sorry. So the s component is going to be x, is going to be y. So the s component here is going to be 86.6 I. 86.6 I. And the y component is going to be 50 what? J, okay? It's going to be 50 J. So this is how you can represent it in terms of its component in unit vectors. Okay. Let's say we have vectors of this particular nature. Let's say vector F1 is equals to 200 Newton, and it makes an angle of 30 degrees. And vector F2 is 300 Newton, and it makes an angle of 45 degrees with a negative x-axis. So let's say they want us to find the vector R, which is summation of vector F1 and F2. Okay, so to be able to do this one, what we must do is that we must find the various components of the vector and then add the various components of the respective vectors. So the components of vector F1 is going to be Fx, F1x, okay, F1x, and F1y. So F1x is going to be 200 cos 30, and F1y is going to be 200 sine 30. So here F1x will give us 173.2 Newton, and F1y will give us 100 Newton. Okay, so vector F1 in terms of unit vector form, to show its directions, we can say 173I plus 100J. Now F2, the component will be F2x and F2y. So F2x is equals to F2, the magnitude is 300, so 300 Newton cos, I will not say cos 45 degrees, okay? I will not say cos 45 degrees, because always we take the degrees with respect to the positive x-axis, okay? And then the 45 degrees is, however, with respect to the negative x-axis, so I cannot use that. So I must take the angle with respect to the positive x-axis. So in this case, I'll have something of this sort. So this is F2, which is equal to 300 Newton. So now the angle I have here is 45 degrees, but I'm supposed to use an angle like this one to the positive x-axis. Okay, so if I do that, then it will be what? 135 what? Degrees. So I'll use 135 degrees. So it will be cos 135 what? Degrees. And then F2y will be what? 300 Newton sine the same 135 what? Degrees. So here I'll have 212.1 Newton, and then here I have 212.1 what? Newton. Okay. So now, what I can do that with respect to finding my resultant vector, which is R, is that I can add the respective components. Okay. So this, before I do that, let me just write this F2 well. So F2 is going to be, wait a minute, here it's going to be negative. It's going to be negative 121.1 degree, 0.1 Newton. Okay. So I'll have I'll have 212.1 I, but it's negative. So let me put the negative sign here. Plus 212.1 what? J. Okay. So now my resultant vector here is going to be 173.2 minus, so plus here, minus 212.1. Okay, so I have to add I to it, plus 100 plus 212.1 J. Okay, so this is what I am going to have. So now if I have this, then what I will get would be resultant vector R will now be minus 38.9 I plus 312.1 J. So this will be the component of the vector R, the resultant vector R. So to illustrate it on a Cartesian plane, it will be like this. You see that the I is going to the negative side. So if I should label my component, my Cartesian plane, okay. Okay, so here the I, which is the x component, is negative. It's negative, so it will go to the negative side here. Okay, so this one is, let's say, vector R x, and my y is what? Positive, so it will go this way. So it will go this way. Let's say vector R what? Y. But I am supposed to find the resultant vector. Okay, I'm supposed to find the resultant vector. So to find the resultant vector, x minus y, I can, my x component was minus 38 0.9 Newton, and it was here. So the y component, I can bring it here like this. And that, so I can bring it here like this. There's nothing wrong in that case. Okay, I can bring it here like this. And that was 312.1 what Newton. Okay. Now I can find the resultant vector. I can find their resultant vector. So their resultant vector here is R. Okay, I can find their resultant vector. So that R is equals to Rx plus R what? Y. Okay, so that R is equals to minus 38.9 I plus 312.1 J. Okay, so if I should resolve this one, I'll have R to be equals to minus 38.9 squared plus 312.1 squared, all square roots. Okay, so I'm going to get 314.5, okay, Newton as my resultant vector. But you can see that R is in the second quadrant. I want to find the angle it makes with the negative x-axis over here. I'll call that one theta R. I'll call that one theta R. So theta R, which is resultant angle, is going to be tan inverse of what? Opposite over adjacent. Okay, opposite over adjacent. In that case, 312.1 over 312.1 over minus 38.9. So when I do that, I'll get 82.9 degrees. That is the angle of theta R. But I told you that always you must find the angle that it makes with the positive x-axis. That means that I must find this angle. I'll call it theta. So now theta is equals to is going to be 180 degrees minus theta R. Okay, so theta is going to be 180 degrees minus 82.9 degrees, which is going to be 97.1 degrees. So now we've been able to completely solve this question by finding the resultant vector and then the angle it makes with the positive x-axis. So if I have an angle like this, let's say this is a vector 50 Newton, and then it has a corresponding y component 120 Newton. So my resultant vector will be here. So here, if I want to find R, it's just equals to 50 squared plus 120 squared, all squared, which will be 130 what? Which will be 130. If it's Newton, I'll just bring the Newton here. Now I want to find the angle that it makes with this x-axis here. I want to find this angle. I'll call it theta R. Okay, so now theta R is going to be the opposite, which is 120 over what? 50. Okay, let me write it again. So theta R is going to be the tan inverse of 120 over 50. Okay, And if I do that, then theta r will give me 67.4 degrees. So mind you that theta r was in the second quadrant, not in the second quadrant, in the third quadrant. So I had here theta r. Now if I want to find theta, which is going to be this way, this is theta. Because the vector is in the third quadrant, my theta is going to be 180 plus theta r. So theta is going to be 180 plus the 67.4 degrees I got. So this will make it to be 274. Sorry, that will not be it. It will make it to be 247.4 degrees. Okay, good. Now let's see, what if I have it this way, and then let's say that here is, let's say, 45 Newton, and I have here to be, let's say, 60 Newton. Okay, so I can just redraw it. Make here to be 45 Newton, and then the 60 Newton, I'll maintain the direction, just that I'll change the position. That is allowed in vectors. 60 Newton. Okay, and my resultant vector will be here. So now this one, if I want to find my resultant vector, so r is equals to 45 squared, I'll make a square root of everything, plus 60 squared. So vector r will be equals to, you can compute this one, okay? I'm sure you should get something like 75 Newton. So now let's find the angle. Let's say theta r. So theta r is equals to tan inverse of what? 60 over 45. Tan inverse of 60 over 45. And then you will get what? 53.1 degrees. But here, you have to know that we have to find the angle with respect to the positive x-axis. That means that the angle in this particular direction we have to find. We must find this angle, okay? Which is what? Theta. So now theta will be equals to 360 minus theta r. So now theta is equals to 360 minus 53.1 degrees, okay? Which, and then theta in that case will give us 306.9 degrees. So to find the angle, if the angle is in the first quadrant, then your theta r is the same thing as your resultant. Your theta is the same as your resultant theta. If it's in the second quadrant, then you have 180 minus your resultant angle. If it's in the third quadrant, then you have 180 plus your resultant angle. If it's in the fourth quadrant, then you have 180 plus, then you have 360, then you have 360 minus your resultant angle. Okay, so that is how it is like. All right. So I can just show it to you on the Cartesian plane. Okay. Okay. Okay, so here you have theta, okay, is equals to your theta, okay. So because it's first quadrant, okay, theta is equal to theta r, okay. Here you have theta here is equals to 180 minus theta r. Okay, here you have theta is equals to 180 plus theta r. Okay, here you have theta is equals to 360 minus theta r. Okay, so that is it. Okay, let's go to the how to use the sine and cosine rule. To resolve vectors. So let me just show by a simple triangle. So let's say that this is angle A, angle B, angle C. So this is side C, side A, side B. Okay, so according to the sine rule, A over sine A is equals to B over sine B is equals to C over sine C. This is the sine rule. And the cosine rule r squared. No, let me not say r squared, okay? So I'll not say r squared. Let me say a squared. Let me take it again. So the cosine rule. A squared is equals to b squared. No, it's small a because I'm talking about the side. Okay, a here like this. Is equals to b squared plus c squared minus 2bc cos, that is the angle opposite to a, okay, cos a. Alright, so this is the sine and the cosine rule. Okay, so now let us see how we can use this sine and cosine rule. So let's say that we have this problem that here to here is 80 Newton and here is 50 Newton. Okay, and then it's a parallelogram. So this is the resultant vector we are supposed to find. And then we are told that the angle from here is 50 degrees. And the angle here is unknown. And the angle here is 20 degrees. All right. So we have to find R. So let's say find R and theta. So let's see how we can resolve a problem like this. Okay, to find R, we can say that R squared is a vector. So it's equal to 80 squared plus 50 squared minus 2, 80, 50 cos. That is, the cos is the angle opposite to that particular side. So let me call here alpha. Cos what? Alpha. Okay. But I don't know the angle opposite to this R. So let me find the angle opposite to this R. If I should redraw this parallelogram, I can say that it's something like this. Okay, and here. Okay, the parallelogram is something like this. Okay, so here is what? 80 Newton. Here is what? 50 Newton. This is what? R, vector R. And I can say that here to here is 50 degrees. Here to here is 20 degrees. Okay, so this theta here is part of the 50 degrees. Okay, this theta here is part of the 50 degrees. So that means that here to here is what? 70 degrees. So I can put here to be what? 70 what? Degrees. Okay, to be what? 70 degrees. All right. And because it's a parallelogram, if here is 70 degrees, then this place must also be what? 70 degrees. Okay, this one I don't know, so I said it's alpha. Here is what? Alpha. Okay, they have to be the same value because it's a parallelogram, so that everything will be 360 degrees. So now, because it's a parallelogram, so 360 degrees is the summation of all the angles. It's equal to 70 degrees plus alpha plus 70 degrees plus alpha. Okay, so I'll have 360 degrees is equals to 140 degrees plus 2 what? Alpha. Okay, so alpha is equals to what? If you do the like terms, 1 what? 0 degrees. Now I can substitute alpha into the equation and get my R. So now vector R squared is equals to 80 squared plus 50 squared minus 2 here, 80, 50 cos 110 degrees. This is cos 110 degrees. Okay, cos 110 degrees. I can rewrite it again so that it will be more clearer. R squared is equals to 80 squared plus 50 squared 280 50 cos 110 degrees. Okay, so this is what we are supposed to find. Okay, so if we should do our computation, we will get R to be equals to, you will have R to be equals to you will have R to be equals to 107.9 Newton. Newton. Okay, now having known R, now that is vector R. Having known R, now we can find the angle theta. We can find theta. To find theta, I can redraw this parallelogram into, this parallelogram consists of 2 triangles. So let's just draw one of the triangles. Here is what? 80 Newton. One thing we have to know is that if this place is 80 Newton, then it means that here is also what? 80 Newton. Okay? And here is also what? 50 Newton. Okay? Because it's a perfect parallelogram. So opposite sides will be equal. So this one into here will be what? 50 Newton. And this is our resultant vector. So this one is coming down here like this. And this one is going here like this. Okay. So now this resultant vector, we found it to be 107.9 Newton. One thing we have to know is that this angle here is going to be 50 degrees minus what? Theta. Okay, what I mean is that this place is going to be what? 50 degrees minus what? Theta. Okay, it's going to be 50 degrees minus what? Theta. So I can represent that one here. 50 degrees minus what? Theta. Okay, so this 50 degrees minus theta, I can call it to be what? Let's say beta. So from here, I can use the sine rule, okay, to find my beta. Okay, I can say that I know that the angle here is what? We know that the angle here is 110 what? Degrees. Okay, we know that the angle there is 110 degrees. So I can say that sine 110 degrees over 107, which is opposite it, 0.9, okay, should be equals to what is opposite it, okay, sine what? Sine beta over what? 50. Okay, so I can say this one. Okay, now I can say this one. So if I should do the all the computation, I'm going to have beta to be equals to 25.8 degrees. Okay, 25.8 degrees. All right, but I also know that beta is equals to 50 minus what? Theta. My main interest is to find theta. So 25.8 is equals to 50 minus theta. In this case, theta is equals to 24.2 degrees. So that is the end of this question. We have been able to find theta and then r also. So take this question to try your understanding on this particular resolution using parallelogram, sine and cosine rule. So here is 50 degrees. Here is 50 degrees, okay? And here is angle alpha. Okay, here is angle alpha. Okay, so find resultant vector r and what? And alpha. Okay, so solve this one and then let me see. I'll just give you the answer so that when you are correct, you'll be able to know. So your resultant vector is supposed to be 14.6 Newton. And your alpha, angle alpha, is supposed to be 18.35 degrees. So these are the answers you're supposed to get if you are correct. All right. So now let's go to one important aspect of the vectors. Okay. Let's see what is called scalar or dot product. Okay. Scalar or dot product. Let's see what is called scalar or dot product. So scalar or dot product examines two particular vectors, and normally what is supposed to result in is that it's supposed to give us a single value that denotes the magnitude. So normally it gives us just a scalar. It just gives us a single magnitude, which denotes what? Scalar. So hence the name of the procedure, which is what? Scalar product. Okay. So now let's say just a few. Okay. Let's say just a few. So suppose I have two vectors. Okay, let's say vector A. This is how you represent. This is how you represent a vector. Let's say vector A is 2, 4, like this, and then vector B is 1 minus 3. Okay, so let's say I have these particular two vectors, and I want to find the scalar product of these two vectors. Okay, I want to find the scalar product of these two vectors. So now the scalar product is such that A dot what? B. The scalar or dot product, this is how you denote it, by A dot B. Okay, now A dot B is supposed to be equals to A1 multiplied by B1, okay, plus A2 multiplied by B2, okay, plus as it may what continue. Okay, if you have A3, then A3 multiplied by what? B3. Okay, so as it may what? As the vector dimensions may proceed. Okay, if it's a 3-dimension, then it's going to be A3 plus what? A3 times B3 also. All right. So now in our particular case here, I'm going to have A dot B is equals to 2 into 1. Okay, 2 into 1. 2 into 1. 2 into 1 plus 2 into 1 plus, let me make it 2 into 1 plus the next one we must take it, which is 4 into what? Minus what? 3. Okay, so A dot B will be equals to 3, no, not 3, all right, 2. It's going to be what? 2. Here it's going to be plus minus what? 12. Okay, let me just make it like this. Okay, so this is what I'm going to have. So now A dot B is going to be what? Negative what? 10. So you see that the negative 10 it gives me is what? It's a single value which denotes magnitude. So there is no direction to it. Hence the name what? Scalar. Giving it the name scalar product. Okay. So this is one method. Okay. What about if I have A dot B such that I have the magnitude of A and I also have the magnitude of B. Okay. And I also have the magnitude of B like this one. Okay. If I have the magnitudes like this one, then to be able to find the scalar product, in that case, I'm going to have A dot B is going to be A dot B in this case will give me the magnitude of A into the magnitude of B equals what? Theta. Okay. If I know of their magnitude, then this is the approach that I will use. Okay. All right. Okay. So now let's see a very simple example. Okay. Let's see a very simple example. Okay. So let's say that vector A is 2, 2, negative 1. That is vector A. And vector B is 5 minus 3, 2. And that is what? Vector what? B. Okay, so let's see these two vectors. And then they want us to find the angle between them. Find the angle between vector A and vector B. Okay, so find the angle between A and B. Okay, so to be able to find the angle, you know that A dot B is equals to what? A dot B is equals to A B cos theta. Okay, so cos theta is the angle between them. Okay, cos theta is the angle between them. Okay, so now cos theta is equals to A dot B over A and then B. Okay, so that's the formula that we use. So that's the formula that we use. Okay. All right. So now what's the angle between them? Okay. We also know that. So how do we find first? Let's find A dot B. We know that to find A dot B is going to be A1 B1, okay, plus A2 B2. You know that this is a three-dimensional matrix, so it's going to be what? A3 what? B3, okay? So this is going to be what? A dot B, all right? So this is going to be A dot B, okay? So let's put in the values and then see. A dot B is equals to 2 into 5 plus 2 into minus 5. No, not minus 5, sorry, minus 3. 2 into minus 3 plus minus 1 into 2. So when we do this, we will have 10. We will have 10 minus 6 minus 2. Okay, so this will give us what? This will give us 2. All right, so this will give us what? 2. Okay. Okay, so this will give us what? 2. All right. Okay, good. All right. So now having known that, let's find the magnitude of A. So the magnitude of A is by Pythagoras, okay, which is going to give us 2 squared plus 2 squared plus minus 1 squared, which will give us what? 3. And magnitude of B is going to be 5 squared plus minus 3 squared plus 2 squared, which is going to give us root 38. Okay, root 38. So now let's put these ones into our formula. Okay, so we will have theta is equals to cos. So theta is, sorry about that. So we will have cos theta. So we're going to have cos theta is equals to, we're just slotting them into our formula. Which formula? Into this particular formula. Okay, into this particular formula. Okay, so we're going to have this one to be equals to 2. Let me write the formula again for you, okay? A dot B over A over B, okay? So we're going to have here, we got 2, and then we got what? 3, and then we got what? Root what? 38. Okay, so that is what we got. So we're going to have this one. Okay, so in that case, theta is going to be cos inverse of what we get here, which is 0.108, which is going to be 84 degrees. Okay, so in that case we find the angle between what, A and B, which is what, 84 degrees. Okay, in that case we find the angle between A and B, which is 84 degrees. All right. Okay, so a matrix can also be written in this particular format. So let's say a matrix can be written as A in terms of their unit vectors. Okay, so 5i minus 4j plus 3 what, k. Mind you, if you have a matrix like this, it's the same thing as what? It's the same thing as when you have A, this one, okay, which is 5 minus 4, 3. Okay, so these two matrices are the same. The ijk is just to show you their direction, that they are on the x, y, and then z plane, or zy, and then they are on the x, y, and z axis respectively. So they are on this one. So this one is I, this one is x, and this one is what? And this one is z. Okay, so the I here, the unit matrix here is what? I. And here, the unit matrix here is what? J. And here, the unit matrix here is what? K. Okay? Yeah. So let's say we have A to be equals to what? 5i minus 4j plus 3k. And then we have B to be equals to 7i plus 2j minus 8 what? K. Let's say they tell us that find A dot B, which is basically find the what? The dot product. Basically, this means that you must find the dot product. Okay, find the dot product. So now here, A dot B is going to be 5 into 7. It's going to be 5 into 7 plus minus 4 into 2 plus 3 into minus 8. So A dot B is going to be 35 minus 8 minus 24. So now A dot B is just going to be 3. Okay? All right. So please keep that in mind. Okay, so let's see another kind of example. So let's say that you have this particular vectors. A is pointing this way and it has a magnitude of what? 15. And B is pointing this way and it also has a magnitude of what? 8. Okay? Now the angle between them is, let's say, 30 degrees. Okay. So now let's say find A dot B. Okay. From what we know so far, we should be able to deal with this particular problem. So let's see how we can do with it. Okay. So A dot B, from what we know so far, is going to be A mod it's going to be equal to the magnitude of A multiplied by the magnitude of B cos theta. Okay, so now A dot B is going to be 15 and then what? 8 cos 30. Okay, so we're going to have A dot B is going to be 120. Okay, and then 120 cos 30. Okay, so when we compute this one, we are supposed to get 103.92. Okay, 103.92. Okay, so I must also tell you about orthogonal vectors. Okay, I must tell you about orthogonal vectors. That when vectors are perpendicular to each other. For example, if you have vector A like this, and then you have vector B like this, okay, and they are perpendicular to each other, that's the angle between them is 90 degrees, okay, then they are orthogonal, okay, then they are orthogonal vectors, okay, and the angle their dot product A dot B, okay, will be what? 0. Okay, then their dot product A dot B will be what? 0. Okay, so please bear that in mind. We might come back to that information later on. We will come back to that particular information. Okay, so now let's talk about what is called the cross product of vectors. Cross product. Okay, let's talk about cross product. It's what? We call it cross or vector product. Cross or vector product. Because we call it vector product because unlike scalar product, which gives you only the direction, this one also gives, unlike scalar product, which gives you only the magnitude, this one gives you the direction. So the name vector. So cross or vector product. Okay. So let's consider two matrix and not matrix, two vectors, and say they are cross or vector products. So let's say that vector A is equals to 3i plus 5j minus 7k, and vector B is 2i minus 6j plus 4k. So let's find their vector or cross product. So A cross B is equals to I, J, and K. 3, 5 minus 7. 2, 6, and then 4. All right? So that is it. So now we are going to have I is going to be just mind the order that I'm doing it. Look at the order very well. 5 minus 7 and then 6, 4. Okay? And then minus j, mind the order very well. Always look at the order that I'm doing it. 3 minus 7 and then 2, 4 plus key. 3, 5 and then 2 and then 2, 6. All right, my 6 here is negative. It's negative here, so it must be negative here also. So this is what I'm going to have. This is what I'm going to have. Now I'm going to, you know that if you are familiar with matrix, okay, this is the procedure for determining the determinant of a matrix.